So the intercept method of graphing linear equations is honestly just another way of doing the exact same thing. So before we get too far into it, I want to talk to you about what intercepts are. So intercepts are basically where a line crosses the x and the y axis. So if this is an equation of the line, and I need to put some sketchy numbers on here, so I could come up with the coordinates of my x-intercept and my y-intercept. So where my line touches my x-axis is my x-intercept. The coordinates for that would be 2 and 0. If I were to take a look at my y-intercept, this is my y-intercept. So the y-intercept is where the line touches the y-axis. This is the y-intercept. And the coordinates for this would be 0 and -2. The key thing about this is the y-intercept is always where x equals 0. Doesn't matter the equation, you can't mess it up. And the x-intercept is where y equals 0. You can see that in just these two examples. So the y-intercept, my x equals 0. In the x-intercept, the y equals 0. And that is really the basis of this intercept method. You're only going to find 2 points on the line, which is arguably less work. You're also going to be subbing in 0, which is my favorite. Now, the downside of this intercept method is that you don't have the backup of that third point. So you can be off in one of your intercepts and your whole line is going to be inaccurate. So when we take a look at these ones, the general way we're going to do it is find the y-intercept first, and to find the y-intercept, x is going to equal 0. Then I'm going to find another point on the line, which is the x-intercept, and to find that, I say y is going to equal 0. I graph those two ordered pairs and draw a straight line through those 2 points with the arrows on the end of the line. I took a big breath because it's drawing those straight lines, which actually did okay in that example there. Let's try one of these. There's no need to solve for y in these. So the intercept method, I start with the y-intercept. And so how I find the y-intercept is I say x equals 0. So those are my instructions. I'm going to sub 0 in where I see x and solve for y. And so I'd have 0 plus 3y equaling 6. That was what I subbed in. Solving for y, I get that y equals 2. Again with this, I think putting it as an ordered pair gives some clarity to the information. So that gives me an ordered pair of 0 and 2. That's where my line is going to touch the y-axis. So 0 and 2 on the graph. The x-intercept is where y equals 0. And so I go back to the original equation and I sub in that y equals 0. So x plus 3 times 0 equals 6. Quick to do, x equals 6. So this gives me another ordered pair. That gives me 6 and 0 as my ordered pair to graph. So out of all of this, I get the 2 ordered pairs that will hopefully be accurate, so I can draw my line on my graph here. And so, oh heaven help me, here we go. Terrible. There is my straight line with the arrows on the end because that line goes on forever. That is the line that is defined by this equation. A few more intercept methods to try. We have the example here given to us, and we're going to do the intercept method to get this onto the graph. So my y-intercept, I usually just put y-int. Somebody asked me what a yint was, and I'm like, no, it's the y-intercept. So that means that x equals 0. That's what the y-intercept is. And so I take and sub in the 0 where I see the x. Oops, that's a 5. Copying wrong. And here I divide by -5 in both cases to get y equals a -3. So I've got a point on my graph of 0 and -3, right? That is a point on my line. And so in this one, I'd have a 0 and -3 as my y-intercept. And it does hit or land on the y-axis. So the x-intercept, that's where y would equal 0. And so in that one, I would have 3x minus 5 times 0 equaling 15. I get 3x equaling 15, took an extra step there. Divide by 3, x equals a 5. And again, seeing this as an ordered pair, I think is worthwhile because that is a point on my graph. And again, only 2 points on my graph, so I hope I haven't made a mistake. Those are the 2 points. And I can draw my horrible line. Yours is going to look beautiful, I'm sure. When I just do it with confidence, it's much better. So a couple more on the page here to do. I'll talk them through. So the y-intercept is first. That's where x equals 0. So following my instructions, I sub a 0 in where I see an x. And now solve for y. Gives me 1 point on my graph that defines my line. And now the x-intercept. And as an ordered pair, I could give my answer. This is also the point that I'm going to put on my graph. Only thing left is to draw my line. Totally missed my other point. Sorry about that. It's terrible. And on to the next. So again, I always start with my y-intercept, where x equals 0. That's why somebody said, what's a y-int? It's a y-intercept. And following my instructions, what I do is sub a 0 in where I see an x in that original equation. This gives me the ordered pair, and I can put that on the graph. For the x-intercept, that's where y equals 0, so following my own instructions. I get another ordered pair so that I can draw my line. Ooh, that one was actually almost okay. So like I said, there's 2 ways of graphing. You may have a favorite. Sometimes different methods work better for different linear equations. I did say that anytime we have these different concepts or strategies, I will give some attention to the horizontal and the vertical lines because they're the oddballs, right? Stuff that we knew before was that, I'll do them in order. Vertical lines looked something like this, right? Just as a general thing. So a vertical line, the x is always fixed. We know that a vertical line has the format that x equals something, right? X always equals something. The other thing that we talked about with the horizontal lines, again on my coordinate plane, and a horizontal line would look something like that. And so with these, it's the y values that are always fixed. And so the general equation of a horizontal line, even though it's weird to see it in standard form, is that y equals something. In these cases, this is, like if we put some points on here, that would be x equals 2, and that would be y equals 2. Just as simple, more concrete examples. So again, the notes here, just picking up where we left off, that was the standard form. And I said this the first time I taught it, but it wasn't in the notes. So sometimes the coefficient on the x or sometimes the coefficient on the y is a 0. And that's how these weirdos come about. That's why the vertical lines come about. So they're always fixed on the x, and the x always equals the same number. The y values can be anything. And so with these ones, they have an x-intercept. You can see up here, there is an x-intercept, but there is no y-intercept. So the intercept method for horizontal and vertical lines totally lets us down. Similarly, if I give equal treatment to those horizontal lines, we know that they're like y equals some number, and that number is always fixed. The y value in all the ordered pairs is always the same, right? They are going to have a y-intercept, clearly, where it crosses the y-axis, but there is no x-intercept. And so the intercept method on these ones isn't going to work. It's absolutely the best for you to understand these conceptually so that you can, deal with these two oddballs. So with these ones, I've said it a lot of different ways, and the students who I've had in the past seem to enjoy me just saying it simply. So this one is that x equals 3. That means that there is a vertical line here where x is always 3. The y's can be anything. So we would just have a line at, oh man, pretend that was on the 3, all the way up and down. X equaling -5. If I were to do that one, where x equals -5, that would be a vertical line up and down there. Vertical lines are hard for me to do. This one, closer to standard form, but still no y variable. So if I were to rearrange it, I could rearrange it and solve for x here. So it looks like the standard thing. I say it's track 2 from both sides. So what x equals a -2. And in that way, it fits what I've been talking about with these vertical lines. So it should be a line straight up and down, maybe straighter than mine, at x equaling a -2. I'll bet you can guess what these last 3 are. So this would be a line at y equaling 4. This is that oddball case of a horizontal line. Same with this one, y equaling -2. X can be anything, but y is always stuck at -2. And the last one, we need to switch it up a little bit so that we can see that y equals 3 and allows us to graph this last oddball of a horizontal line. So the horizontal and vertical lines, like I say, I will give special attention to each and every time we layer on a new concept. So in that way, hopefully conceptually, you'll have a nice thorough understanding of how the oddballs do work with the theory of Chapter 6.